Thank you, everyone, and thanks for having me. So I guess just like a little bit of background. So my name is Streem. I have a company called Vermeer. We build various products, mostly focused on defense applications, AR, VR, kind of computer vision applications. My background's a little bit strange. We started to do work with the Department of Defense about 3 years ago, but my background is actually in film production. So I studied, that's a very young me, so I studied cinematography. I've been very interested in movies and kind of unique camera acquisition technologies my whole life. A movie is really just kind of like a cool way to move a camera. So I've always been very interested in like, how do you get a camera? How do you like kind of like look around corners with photographies or video camera systems? Ultimately, it led me to create a drone cinematography company where I essentially would rent out drones and people to film Hollywood movies. We did Steven Spielberg movies, we did Fast and the Furious movies. I was never really into drones. I was very interested in kind of like the movement of cameras through space. I know it's like a niche, strange thing to be very interested in, but that's kind of what I've always been interested in. The drone was a way to do that, but it was kind of an inelegant way to do it. It required hardware and a flying, you can see the 55-pound flying thing. Ultimately, kind of what movies are, it's like kind of like directing a camera. You want kind of to move a camera from one location to another location. That thing that people do with their hands is kind of a director. They're simulating in their brain what they want the thing to look at and look like. We've obviously all seen, kind of familiar with Minority Report, what he's doing with his hands. I actually was very inspired by Minority Report, but this is a bad reference, but a reference nonetheless. This is from a movie called Enemy of the State with Will Smith. There's a scene where he's in a location and they take a video frame and they're able to like rotate around the video, like magically. I remember when I saw this, like my eyes rolled to the back of my head, like how on earth could they possibly do this? They're digitally moving the video frame around the person. But it was inspiring nonetheless. So I had this idea to kind of build a tool to kind of do, what if we could kind of take video and kind of generate these like 3D avatar system based off of video. About in 2020, my company got handpicked to essentially join this Techstars. I don't know if people know what Techstars is. It's kind of like a accelerator. The DoD is very interested in finding unique technologies and help inject them into the Department of Defense. So I got kind of like a 5-month crash course in how to work with the Department of Defense to essentially incubate and build this technology for the warfighter. So the DoD has cinematography cool. They call it ISR, which is essentially intelligence, surveillance, and reconnaissance. Oftentimes, if you work at DoD, there's like a lot of charts showing drones and helicopters. There's a lot of cameras on a lot of defense platforms. There are cameras on tanks, drones. There are cameras on helicopters. There are even now cameras on body-worn cameras on Microsoft, a beefed-up Microsoft HoloLens. It's called the IVAS system. I think it was a $22 billion contract given to Microsoft for this technology. But the problem with all this stuff is that when you're shooting like a movie or you're taking pictures or full motion video, you only have one perspective. You have the perspective of the sensor itself. Even with something like this, a 360 camera, you are kind of trapped in the perspective of the location of the camera system itself. So you have single perspective, but then the question was, well, what if could we build something that gives us, when you're playing a video game, you could either kind of play first-person shooter or you could play third-person shooter. Third-person shooter is often more helpful because you kind of have like this God's eye omniscient perspective of the world. So is there some way to kind of create a third-person view? And again, I would argue that this is kind of a third-person view. You kind of detach yourself from the perspective of the camera and you can kind of see things kind of more globally. So we decided to build it. So essentially what we do is we start off with this kind of pre-existing 3D terrain map of the environment that we get from like Google Earth or satellite imagery. And this was an experiment we ran just just a month or two ago. So we started with this pre-existing 3D map. Here you can see we just had some ground vehicles. At the top, we just had a couple of GoPros with the GPU and this pre-existing 3D terrain map on it. There's a tremendous amount of data here because you have 1920, 1080. Each car has multiple cameras. So there's a tremendous amount of data you need kind of send somewhere, as you can see here in this this graph to the bottom right. And again, you're just kind of seeing the perspective of the camera itself. We have image algorithms or detection algorithms that are detecting the vehicles, so you can kind of see vehicle A, vehicle B. So in the top left is full motion video from kind of like the multiple camera feeds. The bottom left is the pre-existing terrain map. So we're actually able to localize the position of the vehicle. So you don't need GPS. So essentially we're comparing what the cameras are seeing to the pre-existing map that's on a hard drive on the platform that has a GPU on it. And then we're able to not just tell us where we are. You kind of see the blue dot is what we call visual positioning system. The red dot is GPS. And then the green dot, as you can see here, is actually where that thing is over there, that other vehicle in the top left. That's the position of that thing over there. So I'm not just able to tell myself where I am based off of solely computer vision, but where the other things are around me. And what this allows you to do some very cool things. So now we can essentially take that metadata of those vehicles and inject them into a Unity project and animate these avatars. So these vehicles, so what you're looking at is a God's eye view from just multiple full motion video cameras, where we're essentially creating this God's eye view real-time 3D visualization. And the really cool thing is there's almost no bandwidth, as you can see in the bottom right, because we're not sending millions of pixels. We're simply saying, hey, over there at ABC location, there's this vehicle. At ZYX location over there, there's another vehicle. So just send those kind of 4 numbers and then represent them as these pre-existing avatars. So now you can make this interactive. You could add notes. You could kind of put this into a IVAS headset system. You could drop messages. This is just a Unity experience, essentially. You could obviously kind of create these cinematic looks. You could see the perspective of what other people are seeing by kind of like going into their helmets or their headsets. Now you could kind of do that thing where you could kind of move the camera anywhere in space. And you're no longer kind of bound to the confines of, the location of the sensor. Cool. So that's it. I'm happy to kind of answer questions. My company, we also build like virtual reality tools to kind of visualize and command and control drone swarms and satellites in space. So I'm happy to kind of talk on anything related to computer vision, geospatial kind of registration. I know a lot about working with the defense. My company's been very successful in a short period of time working with the DoD and aerospace primes and things like that. So if anybody has any questions on any movies, love to talk about movies, anything you'd like. So appreciate it. Thank you. Yes?
Hi, thank you very much. It was really informative. So what I would like to ask is, in what form does that information reach the people on the ground, the soldiers?
It's essentially, it could be like, it could be any form. I mean, what are the soldiers on the ground looking at right now? So it's quite frankly, it's TBD. I mean, what we're generating is we're generating kind of 4 or 5 numbers of where something is and the pose of it, like the orientation. So if the vehicle's that way, looking this way, looking that way, where it is globally on the position of the Earth. That's what we're generating. So it's XYZ, what is it, and what poses it. So it's like 5 numbers. You could display that. So we have a display, like most soldiers carry what's called like a ATAC, essentially a beefed up Samsung smartphone that they kind of wear on their chest. So we could generate a blue dot, essentially like a blue pin or a couple markers on this sort of headset. I think my kind of where we're going with it is that the IVAS, I'm sure people have heard of the IVAS system, is that you could essentially take those camera systems and create like avatars of things that you individually don't necessarily see. Does that make sense? Yeah. If you have like an
Can I just give you this?
Yeah, that's correct. So if you have like an airborne sensor and I'm on the ground and that airborne sensor sees things from like its drone shot, okay, then that sensor will say at XYZ location there's a man, at ZYX location there's a truck, and then the person on the ground could see like a arrow avatar pointing to that thing and be able to kind of not just see it from his perspective, but see kind of like a 3D visualization of the environment. So he's like a god, like God's eye view, and he's able to kind of like move and manipulate what he sees from any perspective. Does that make sense?
Yeah, it definitely makes sense. So, like, if I understand correctly, there is basically like a live digital twin, like a live model of the environment, right? Like running some on the server, like on a real time.
It's running. The magic. There's a magic trick going on here. The magic trick is that the platforms have the 3D map already baked in, so it's kind of a camera that goes into a little computer, little GPU from NVIDIA. The little GPU is connected to a hard drive. That hard drive already has a pre-existing 3D map on it. So all the platforms have this. So the only thing we need to kind of transmit is, hey, there's a ice cream truck at ABC location. There's a missile at ZYX location. So you're kind of just like stitching that data together and populating it in the pre-existing 3D map. Because who cares about sending the data of the roads, the mountains? All that stuff is fairly consistent. So we're only updating the things that the user cares about.
Mm-hmm. Yeah, sounds great. Thank you very much.
Cool, thanks.
I'm just going to give you the microphone. 1 second.
Hi, it was really interesting, thank you. I suppose my first question was answered around how real-time it is, but in terms of, you talked about how you've basically got the data about the terrain already on the devices.
Yeah.
Do you have any challenges in keeping that up to date? For example, if they build a bridge somewhere and it's not on the map you've got, is that improved?
Yeah, so the map provider that we're working with is like, they have hundreds of satellites in space and they have a precise global 3D map of the environment, which they're constantly updating. I think the constant depends on the area. I mean, if you're working with the DoD, the areas of conflict, it's very up to date. Okay, like we're talking potentially daily up to date. But even if it's not the algorithm, I mean, the fact of the matter is the algorithms are robust enough that like it's looking at enough of the environment and making a most probabilistic guess as to where you are based off of, we're not just doing the 3D map match, we're also doing visual odometry, we're doing SLAM, there's a temporal element as well. So if you know over here, I'm highly confident I'm standing over here, and then you move a little bit over here and the map is different, you're not going to assume you're in a totally different location. So it's pretty robust in most instances that we've uncovered, unless the terrain was totally devastated by some sort of massive explosion, that would be challenging.
Okay, so I suppose you've got the opportunity as well using the SLAM data to kind of reconstruct that map as well.
Yeah, I actually didn't show that here, but that's exactly right. So we're also performing SLAM, so we're building a better map as those vehicles are driving. So future missions that they're going there will have that better, more up-to-date map.
So it's kind of like a feedback loop then.
Yeah, exactly. Yeah.
Great.
It's like that, like it's like a network effect, sort of a classy, trendy thing. But like I could talk about the business model of defense a lot and why that may or may not be a good thing.
Any other questions? Yes, I will just give you a microphone. Hang on. Sorry, it's just for the recording.
Can you just elaborate on what you just said, like the business model of the defense stuff? And
yeah. Have you worked in defense at all, or? So DoD. I mean, that could wax poetically a lot about this. I mean, they're kind of like an old-timey buying kind of large organization. They like physical things because they could see them. That's just like a classic sort of a thing. We're really only building software. We're building like software that goes onto onto GPUs with cameras primarily. So our business model is really to charge a recurring revenue subscription software, which they're starting to do. And as kind of like older people from the DoD kind of like retire, the younger people are more kind of familiar with this like Adobe subscription, Netflix subscription sort of a thing. The business model of kind of like a network effect of data, as you collect more data, we save the data and we do better things. I mean, that's really like, guys like Palantir have really like solved some of that stuff, but like you have to do a lot of education with the customer. I could get more specific, but like it might be boring for most of like this. So if you want to like talk more about it, I'm happy to answer more questions after. I don't know, did that solve any of your questions?
Oh yeah, I just don't know anything about the defense industry. So I just
Gotcha.
need to learn more.
Gotcha.
Thank you.
It's also just not like it's not just like you could sell something to the DoD. There needs to be requirements. Somebody in a requirement shop needs to make a requirement. There needs to be something written into the congressional budget. Like you need kind of like a trifecta of 3 things to happen to kind of like actually make like a sale with the DoD. It's complicated. I myself, I've only been doing this for 3 years. My whole sales team is guys who've been doing it for 20 years at like much bigger companies. So like, I had to hire people who knew more about it than I did.
Okay, any further? Yeah, I see one in the front here. Yes.
Thank you. Sorry, I apologize. I arrived a bit later, so I don't know if you talked about it in the beginning, but you said that you add data to the map that you already have,
Yeah.
like every time that somebody passes in that spot. How do you get the initial map? Like, do you scan it with
So we could use any map that we want. The cool thing about the DoD is they have things that fly over places with high-end lasers and high-end photo. I mean, they're doing constant mapping, but regardless of that, we work with a map provider that has a satellite imagery, global satellite imagery. They take oblique and stereo satellite images, and they generate a highly accurate, like meter-level resolution 3D map anywhere in the world. That map that you saw was from that provider. And with that, you could, I like that map because it's very accurate and it's global. It's very expensive. DoD has lots and lots of money.
Thank you.
Sure, thanks.
Anybody else? Yes. Okay, he was like a microsecond before you, so we're going to do like this.
Thank you very much. Very informative, Brian.
Sure.
Where do you see your technology in like 5 years? What can we expect? Like integration with additional sets, like sensors?
Yeah. There's a technology. So this technology, we call it AVA, which is like short for avatar, because that's what we do. We're kind of like generating like these avatars in a 3D environment. The technology that's kind of a foundational is what I call visual positioning system, VPS. The DoD is incredibly concerned about losing GPS. Right now in Ukraine, there's no GPS. The Russians have turned on, anyone with an electrical engineering degree could turn on a little device, build a device, turn it on, and it showers the environment in electromagnetic noise, or GPS noise, essentially rendering all GPS useless. You could also spoof GPS. I could think I'm standing over here when really I'm over there. So I think our immediate need is our visual positioning system, essentially to replace GPS. And the beautiful thing is, you can't spoof it, you can't jam it, because and it doesn't emit a signal. So you can't do anything to kind of, it's just like a camera. The camera goes, hey, where am I standing? So it's all internal to the device. So I think the immediate thing is visual positioning system, which is kind of like a augmented reality. If I want to place things in the world, I kind of need to visually be able to, so that's kind of like a cousin to that a little bit. So visual positioning system first is kind of like the base product, I think, and then being able to kind of generate geo-registered avatars. my background is in like film, so I'm like, I kind of have like these like crazy cool ideas. I'm like, oh, like and I was like a little, I'm like, I wonder if people are gonna like this kind, and like the reaction to this, like people have seen, the cool thing is I grew up on sci-fi movies, sci-fi war movies, so I kind of got into the DoD, I'm like, oh, they don't have any of this stuff. We should build it for them. And the people in the DoD, they've seen those movies too, and everyone's upset that they don't have all that cool stuff either. So there's a lot of kindred hearts that I've met in the defense industry where like this will be applicable. I think it will be applicable in the low bandwidth range. The biggest line item that they spend on money is sending full motion video from a ground, from a camera to a satellite. That's tremendous amounts of, that's hundreds of billions of dollars they spend on that. If they could reduce the bandwidth of that through a very clever SLIS system like that, I think it could kind of replace full motion video.
So we'll just take the second question over here. Thank you.
Hi. So thank you. Partially answered my question already. I was wondering, like, the whole idea is now to have a processing of the video locally on the device.
Exactly.
But do you consider, like, for the future to have the application to move the processing to some computing centers, like, for example, local computing centers on the battleground with BTS, local BTS and such? The reason why I'm asking, because this could allow, for example, if the device on the soldier was broken, he could use his mobile phone, for example, to be able to help with the localization.
I kind of, there's kind of like a trend in the consumer world. I think the company before was kind of talking, oh, we're going to process it all in the cloud and stuff like that. I think that's actually like the opposite of what's going to happen in the defense world. I think in the defense world, they want to do most of the processing, like soldier, like on on the vehicle, on the person themselves, because they don't have the luxury of 5G. They don't have the luxury of cell phone towers. They have the luxury, they have satellite communications, which is really expensive and low band, and there's tons of things being piped through the satellite. So I suspect that we're going to gravitate more towards locally processed stuff. And I guess I don't like, maybe it's just because like that's where I work, like in the aerospace. I just don't understand. I mean, I don't get the whole, like, yeah, like the processing is going to be way better on the smartphones. Like in the next year or two, we're going to be able to run all sorts, like, 5G, 6G, yeah, that's going to get better. But it's like if you can process it on the phone, like why not? I guess it's battery. I guess it'll be good for different things. For defense applications, I think that they mostly want it locally processed. Because anytime you have to send a signal, somebody could interfere with that signal. And people are actively interfering with stuff.
Got it. Thank you.
Yeah. Thanks.
All right. If there's one last quick question, we have time for it. Anyone? No? Yes? 1 second. Here you go.
All right. So I have one more question concerning the how much, let's say, is the system being used right now?
The visual positioning system is being used on several aerial platforms.
Okay, but like kind of on the ground. Do you know approximately like?
So we are not fielding this system yet, but the visual positioning system, which I showed you a little bit of it. That's being fielded on several kind of aerial platforms.
All right, thank you.
Sure.
Great, thank you so much. Okay, let's give a big round of applause to Brian.
Thanks, everyone.